Hello everyone, this is Tool and Solution. Title: Sentinel-1 versus Sentinel-2 on Snap13 software from the ESA. Before starting processing Sentinel-1 radar image data, it would be better to navigate your region of interest with the Sentinel-2 multispectral image. Perhaps human eye can see visible wavelengths include blue, green, red, and provide a better chance to navigate appropriately unfamiliar area. Thus, Sentinel-2 multispectral image would be good start first in your region of interest. Extending infrared wavelengths display as a false color composite can be also beneficial. Anyway, here is a step-by-step pre-processing Sentinel-1 data as follows. First, apply orbit file. This process is updating position and velocity information metadata from satellite for precise geocoding. The orbit state vector are available day to weeks after creating the product. So after finish apply orbit file as a second step, you can choose GRD border noise removal. In the case of infrared wide mode, shortly IW mode, eliminating low intensity noise affected by artifact. Processing of raw data into level 1 product promote step-by-step processing result in this artifact at the boundary at the image. As a third step, actually is popular. I would like to introduce thermal noise removal in order to minimize discontinuities, reducing additive noise effect in the multiple subswaths and effect discontinuity issue. Bilinear interpolation is applied for any pixel that fall between points in the lookup table. As the next step, calibrate or radiometric calibrate. It means converts raw pixel values such as digital number into meaningful calibrate synthetic aperture radar backscatter. Calibrated SAR images are crucial to the quantitative approach of synthetic aperture radar data. It's significant to process radiometric correction to SAR image, representing logically radar backscatter from bouncing back surface or terrain. It's also significantly important for intercomparison among SAR images which are collected from different sensor, platform, temporal acquisition, mode, and the system. After successfully finish calibrate radiometric calibrate process, as the next step, you can have a multi-looking. So it is necessary because the SAR raw image has an inherent speckle noise. this inherent spectral noise, so it would be better to process several images that are incoherently combined for improvement of image interpretability. It means like the better interpret to image from the target. So next step, sometimes it's optional, but it also important pre-processing of Sentinel-1 SAR image. So there is a speckle filtering. In this case, we apply single product speckle filter. But this step introduced the raw synthetic aperture radar image originally have as I mentioned earlier, inherent salt and pepper kind of a textural that is defined as a speckle noise. It causes hard to interpret feature within the SAR image. Irregular constructive and disconstructive interference of a deep phase but coherent return wave from the target make an inference of a speckle noise within each resolution cell, like within each resolution pixel. Choose the Lee sigma filter method within 5x5 window size. However, you could apply the different filter method over window side using Snap software. You could select multi-temporal speckle filter with the default setting, depend on your scientific and engineering purpose. As the next step, I want to introduce geometry, range Doppler terrain correction, shortly called TC. Because of topographical variation and dislocation of a satellite in the orbit, the distance could be distorted or twisted in the SAR image as displayed in the figure on the current screen. There are distortions from vertical gradient and horizontally gradient from the terrain on the ellipsoid or Earth's surface. Image data was not associated correctly with the sensor, neither location straightly, result in the some distortion. Do you understand? Alright. So therefore, terrain correction help better geometric representation image from the real world example. So in this Snap software version 13, so I use a range Doppler TC with a digital elevation model with a SRTM. It's meaning Space Shuttle Radar Topographic Mission. You could choose your preference of a digital elevation model if you have a better DM with a finer spatial resolution. As a last step, conversion linear to from decibel. The radar brightness of a SAR image, the pixel, actually calculated to the log scale. So it is for the better interpretation. Now all pre-processing steps for Sentinel-1 were completely done. Depending on Sentinel-1 product with a diverse mode, there may be the necessary additional step of pre-processing. You are ready to compare between Sentinel-1 image and Sentinel-2 image over Sudbury, Ontario, Canada. So now you are going to look at image complete process from Sudbury, Ontario, Canada, acquired from Sentinel-1 data as well as the Sentinel-2 data. Sentinel-2 data belong to optical or multispectral imaging and the platform, while Sentinel-1 is the radar system. All of us already familiar with human eye and optical imaging. As a first step, it would be better to navigate unfamiliar area with multispectral imaging like Sentinel-2. Then, once you feel comfortable, please moving forward to explore your region of interest with the Sentinel-1 radar imaging. So now you are ready to compare between Sentinel-1 image and Sentinel-2 image over Sudbury, Ontario, Canada. You may need to identify the same projection or the same geographic projection between two products. However, it's optional. How do you look at different features from optical and radar imaging? Do you find any interesting feature that you have found out? All captions or transcripts are available below this YouTube video. Please check it. Thank you for your watching my YouTube video. Have a wonderful weekend. Bye for now.